Okay, so the lesson today is in regards to kinematics. As we said on the course outline and on, we will mention this even later on in Physics 20. Kinematics is that part of mechanics. So kinematics and dynamics are sometimes called mechanics, and some textbooks treat them as one. Kinematics, the biggest questions on kinematics is how is the object moving? So things like what is the velocity of the object? What is the speed of the object? What is the displacement of the object? How far the object was moving? So what is the distance that the object is obtaining during that particular time? Is the object moving in a uniform or non-uniform motion? If the object is moving with a uniform motion, then acceleration is equal to 0. And if it is moving with a non-uniform motion, then acceleration is not equal to 0. So the biggest question on kinematics is how is the object moving? And in order to identify how is the object moving, we have to state and figure out one of those quantities, or sometimes more than one. So for today, what we will do is we will look at some of the examples that we have here, and then the topics that we will treat are speed, distance, and displacement. Now, when we talked about vectors, I don't know, you should remember this. When we talked about vectors, we said that vectors are physical quantities that in order to fully describe, you need to identify the direction and the magnitude. And then we listed some of the most important physical quantities that are vectors and they're corresponding in scalars. So velocity, if we create again a table, vectors and scalars. Velocity is a vector quantity and the corresponding quantity in scalar is speed. And then displacement is a vector quantity and distance is the corresponding quantity on a scalar. Time is a scalar quantity. Time doesn't have direction. It starts at 0 and then it goes on. It starts at the moment that we are looking at the motion and then it moves forward. Acceleration doesn't have a scalar corresponding quantity. And then what we have added on that table are force and field strength, different field strengths. For today, we'll focus on those four quantities: velocity, displacement, speed, and distance. So let's take a look at the first example that we have here. It's saying an object travels 510 kilometers an hour. What is the average speed of the object? As you see here, what is given is distance. So we don't have the information in which direction is the object moving those 510 kilometers. So are you looking at the screen, guys? So distance is 510 kilometers. And then this 510 kilometers are obtained in 4 hours. And what we are looking for is the speed. Now, the average speed is total distance over total time. The total distance that the object is obtaining is 510 kilometers over total time that the object is moving is 4 hours. And now if you reach into your calculator, 510 divided by 4.0, the calculator will give you 127.5, and the units are kilometers per hour. However, what it is that this distance is on 3 significant digits. Time is on 2 significant digits. Therefore, the final answer has to be on 2 significant digits. How can we write 127.5 into 2 significant digits? 1.3 times 10 to the power of 2 is the way that we will express our answer into 2 significant digits. Because what we do is, 127.5, we have to express it with 2 significant digits. So we will move the decimal point between 1 and 2. So we'll have 1.275 times, since we are moving the decimal point to the left, will be to the power of positive 2. However, this part here, the times 10 to the power of 2, is not counted in terms of significant digits. So we will look at the decimal part. The decimal part has 4 significant digits on the way that it is written. Since we are looking for 2 significant digits, then we will stop here at this place. So we'll go 1 point. Since the digit that is coming after 2, since the digit that is coming after 2 is 7, is greater than 5, then we will round it up, and then the answer will be 1.3 times 10 to the power of 2 kilometers per hour. Okay, so let's move now to the second example. And what we have here is that the distance is equal to 6.5 kilometers. And the time is equal to 31 minutes. And what we are doing is we are looking for the average speed. But the units that we are looking for is meters per second. So the very first thing that we do is we convert the 6.5 kilometers into meters per second. How many meters are in 1 kilometer? The way that we will convert it will be 6.5 kilometers. If you have seen the video on converting, then you will know. It is multiplying it by a ratio of 1. When we are saying 1 kilometer is the same as saying 1,000 meters. Or if we are saying 1,000 meters, then it's the same as saying 1 kilometer. What is the ratio that we will multiply now so that kilometers that are in the numerator is cancelled? 1. Good, it's good. 1,000 over 1 because over 1 kilometers, because kilometers and kilometers are cancelled out, and the units that you are left with are meters. So this will be 6, 5, 1, 2, 1, 2, 3, yeah, meters. Okay. And now we have time in minutes. Let's convert time in in seconds. So in 1 minute, we have 60 seconds. What is the ratio that we are multiplying it by now? 60 over 1 or 1 over 60? Will be 60 seconds over 1 minute, because minutes and minutes are canceled out. And then in your calculator, you go 31 times 60 is equal to 1860 seconds. The units that you are left here are seconds. When you have everything into the units that you are looking for, then it is simply to apply those values into the formula. The average speed is equal to total distance over total time. So total distance is 6,500 meters over total time is 1860 seconds. So the speed will be in your, the answers were on all of the chart were 3.5 meters per second, which is a bit different from what you have in your calculator, and the reason it's the correct one, but the reason that you have different from what the calculator is giving you is because you are writing the final answer to the correct significant digits. So this will be 3.5 meters per second versus what the calculator is giving you, that is 3.4946 and so on. Questions? I have an object traveling 60 kilometers per hour for 20 minutes. How far is the object? How far is the object moving? So let's start by sorting what is given. So what is given here is the speed, and it is 60 kilometers per hour, and the time is 20 minutes. And what they are asking is the distance. Okay, so now on the formula, what we have is that the average speed is total distance over total time. Total time. We are looking for the distance, so the total distance will be average speed times total time. However, when we see this, we notice that the speed is at 60 kilometers per hour and time is at 20 minutes. So they are all different units. You have two options here, either to convert everything into meters per second and seconds, or to convert time into hours. Now, if I was you, I will prefer to do as less work as possible, and then the one that will be less work will be to convert time into hours. I want you to do this on your own while I am waiting for your answer. So we have 20 minutes and we want to convert them into hours. So in 1 hour, we have 60 minutes. Or if we have 60 minutes, then we will have 1 hour. What is the ratio that we have to multiply it by? 1 hour over 60 minutes or 60 minutes over 1 hour? Okay, so the answer is 1 hour over 60 minutes, because minutes and minutes will cancel out, and in order to cancel them out, we have to have them in two different places, one in the numerator, the other one in the denominator. So then the answer will be 20 over 60 hours, or 1/3 hours, or if you want to write it in decimals, it will be 0.3 repeating hours. So now that we have the time into the units that we want it to be, then we find the total distance as 60. And now look at the units, guys. Kilometers per hour times 1/3 hours. So again, hours and hours will cancel out, and what you are left with is kilometers. And this will be equals to 20 kilometers. On the other example, we have how much time is required for an object traveling 50 meters per hour to travel a distance of 6.0 kilometers. Okay, good. So now, what do you think that we should do? What is given here, first of all, is that the speed is equal to 50 meters per second, and the distance is 6.0 kilometers. And we are looking for time. First of all, I want you to tell me, as you notice here, we have two different units, meters per second and kilometers. And we want to have the same thing, like so that we can cancel out. We cannot cancel meters and kilometers. We need either meters and meters or kilometers and kilometers in order to cancel out. What do you think that is the easiest way to convert meters per second into kilometers per hours, or kilometers into meters? So the answers were kilometers to meters. It's great, and it is the easiest one to do. So let's start converting them. We have 6.0 kilometers, and same thing as in the previous examples. In the previous example that we did, we will multiply it with 1,000 meters over 1 kilometers. So kilometers and kilometers are canceled out, and then we will have 6,000 kilometers. And now on the formula, we have that the speed is equal to total distance over total time. We are looking for time here. So from here, we can find that total time is equal to total distance over average speed. Now we have everything into, oops, this is meters, not kilometers. Now we have everything into the proper units. So then we'll go 6,000 meters over 50 meters per second. And as you see here, meters and meters are canceled out. And then we are left with 60, what is it? 66,000 divided by 50. It is 120. And look at the units now, guys. It is 1 over seconds. And when we see this, so 1 over seconds is the same as saying it is 120 seconds. But we have the significant digits here are in 2, and the final answer is on 3. So we write it in scientific notation form, 1.2 times 10 to the power of 12 seconds. And this will be our final answer. Do you have any question on this? Let's move now to another example when we are converting 40 kilometers per hour into meters per second. We have seen a similar example like this on the previous videos when that are posted on D2L, and you can refer to that example as well. However, So it is 40 kilometers per hour. And now we start converting them. So first, let's cancel out, let's convert, not cancel out, let's convert kilometers. So the ratio that we have to multiply by is 1,000 meters over 1 kilometer. Why? Because kilometers and kilometers will cancel out. And up to that point, what you will see is meters per hours. The units that are left are meters per hours. And then we have to convert hours into seconds. We know now, you can go in two ways. You can go hours into minutes, minutes into seconds, or you can go straight to seconds, because we know that in 1 hour we have 3,600 seconds. So hours and hours are canceled out. And then what do you have at this point is meters per second. And those are the units that we are looking for. So then you multiply with whatever is on the numerator. So this will be 40.0 times 1,000 times 1, which you don't have to write it, and it's good to not write it, divided by 3,600. And the units are meters per second. So now in your calculator, please tell me what is the answer. Good. So it is 11.1 meters per second. And this is at the correct significant digits that we started with. 40.0 has 3 significant digits, and 11.1 has 3 significant digits. Questions? And discuss this question together. Okay, so when you see something like this, and they are asking you for the average speed, the tendency of some students is to take those two average 1,850 kilometers per hour and divide them by 2. Why? Because they are saying that, oh, well, I have two parts of the motion here, the velocity 1 and the velocity 2. I take the 2 and then I average. But this way is not the proper way to calculate the average velocity, because even on the formula, we said that the average velocity is total distance over total time. So remember this. This is a key formula for the speed. It's the total distance over total time. Since the object is moving 1,800 kilometers at 1,000 kilometers per hour, and then 2,200 kilometers at 850 kilometers per hour, then we have two different distances at two different speeds. So first, let's find the total distance. The total distance will be the distance for the first part of the motion plus the distance from the second part of the motion. So this will be 1,800 kilometers plus 2,300 kilometers. So the total distance will be equals to, what do you have, guys? 4,100 kilometers. And now we have to calculate the total time. So total time that the plane is moving, is traveling, is time that is moving on the first part of the motion plus time that is moving on the second part of the motion. So time that is moving on the first part of the motion is distance on the first part of the motion over velocity on the first part of the motion. Those are the same units, so we don't have to worry about the units. it is 1,800 kilometers over 1,000 kilometers per hour. And now kilometers and kilometers are canceled out, and then we will have 1.8 hours for the first part of the motion. Let's move to the second one. So the second part of the motion will be the same formula, but with the index 2. The distance 2 over speed for the second part of the motion. And the distance for the second part of the motion is 2,300 kilometers over 850 kilometers per hour. And again, kilometers and kilometers are canceled out, and then we will have 2.71 hours for the second part of the motion, which will give us the total time as 1.8 hours plus 2.71 hours equals to 4.51 hours. And now we can find the average speed as the total distance over total time, 4,100 kilometers over 4.51 hours. And this should be 911 and 11 kilometers per hour. This is what we have now as a situation. We have roller blader A and roller blader B that are, I will make B with different colors. So, this is roller blader A and this is roller blader B. So B is giving A 5 seconds. 5 seconds start ahead. And then A is traveling with average speed of VA is 5.0 meters per second, while VB is able to travel with a speed of 7.5 meters per second. So they are traveling on this direction, let's suppose. Okay, and then at a certain point here, B reaches A. Okay, so this is the meeting point, let's say. And the distance that they are traveling is, let's say, X. We don't know that. We don't know that. And as everything that we don't know in math and in physics, we assign it with a variable. Okay? Is it clear as a situational diagram? The B will obtain, they actually both will obtain distance X, because A will have a head start and then B will start after 5 seconds. Okay, but they both will obtain the same distance X. Okay, so now the time that A is traveling, let's assign it with T. The time that B will travel will be whatever A is traveling minus 5. Or, because B is giving A a head start of 5 seconds, or T minus 5. Is this clear, this relationship? How did we come with this relationship? So now again, we will take a look at the rollerblader A. The velocity or speed of this rollerblader is 5 meters per second. And this is as a result of the distance that it is moving over time of this particular person. Distance is x because they start at the same point and they meet at the same point. And time is t. We assigned it as t. You can leave it as ta, but just for simplicity, we assigned it as t. From here, we find that x is equal to 5 times t. And now when we move to the rollerblader B, the speed of it is 7.5. And this is as a result of the distance, so VB will be equals to DB over TB. Distance is the same because they start at the same point and they meet at the same point. That we don't know, we said that is x over TB, that from the relationship that we were just figured out before is time that A is traveling minus 5, because B is giving 5, B is giving A 5 seconds head start. From here, we find this relationship. So now we have two relationships in terms of x. One that is 5.0 times time, and the other one that is 7.5 times t minus 5. Here, the whole video tape. Now is the same. It's the matter of equaling those two relationships. So we'll have in one side we'll have 5.0 t is equal to 7.5 t minus 5. So this is a linear equation. We can solve it by distributing 7.5 to t and to negative 5. So we'll have 5.0 t is equal to 7.5 t minus, what is 7.5 times? It's 37.5. And then combining like terms, you will find that t is equal to 15 seconds. And this will give you the answer to question A. And then, at what position B will catch up with A, which is question B. Then you can use any of those relationships. Either you can use 5.0 times t, or you can use 7.5 times open brackets t minus 5. Both of them are equal. They should give you the same answer, and this will be a point where you will check and will give you the same answers. So I will pick any of them. Then x will be equal to 75 meters. And this will be the answer to part B of the question. Do you have any questions on time? So those are the 3 practice questions. So the third one, it's a bit more similar to the last example that we did here. So it is kind of more difficult. The answers are on the brackets here. So for the first one is 0.23, for the second one 1.67, and the third one is here on the brackets. I would please you to work on those questions for now on 5 minutes, and then we will come back as a group. So this part of the lesson is dealing, as I said, more with the difference, discussing the difference between distance and displacement. we know now that distance is a scalar quantity and displacement is a vector quantity. And the difference between the two, a vector quantity, in order to fully describe, it needs the magnitude and the direction, versus distance just need the magnitude along with units, but just the magnitude. So now we have a situation like this. A person walks 10 meters east, then 20 meters west, and finally 10 meters east. What is the person's distance and displacement for at each point of the trip? So we'll draw that in physics is known as the situational diagram. Situational diagram is a simplified way, a picture of what is happening in the motion. So in this case is what is happening with this person, and we can draw a sticky person or nothing. This person is moving 10 meters east and then 20 meters west and then 10 meters east again. So this, I will draw the situational diagram. This is the starting point. So this is where it starts. And it is moving 10 meters east. So this is the first part of the motion. Now this is a displacement. Why is it displacement? Because it is telling you what is the direction. And then from here, it is going 20 meters west. So 20 meters west. This is D2. And again, is a displacement. Why? Because it is going, it is telling you the direction. And then the third part of the motion is 10 meters east. D3. So let's talk and discuss now what is the distance and what is the displacement. The distance is how much is the object moving? How much is this particular person moving? So it is going 10 meters, 20 meters, and then 10 meters. 10 meters, 20 meters, and then 10 meters. So we don't care about the direction. So when we are finding the total distance, then we add whatever, let's make it, then we add whatever distance is the person moving. So D1 plus D2 plus D3, yeah, Brady, you're right, plus D4. So D total will be 10 meters plus 20 meters, adding them simply, plus 10 meters. So D total will be 40 meters. Now, when we talk about displacement, displacement is a vector. And always keep this in mind for displacement. Is a vector that starts at the starting point of the motion and ends at the end point of the motion. So displacement is a vector that start, you simply draw a vector. Start at the start point of the motion and ends at end point of the motion. So in this case, since the start point and the end point are the same, the displacement will be equals to 0. But let's see how can we, so logically this is it. But let's see now mathematically, how do we do it? So total displacement will be displacement 1 plus displacement 2 plus displacement 3 plus displace, oh, no, just 3, not 4. Sorry, 3. Now, displacement 1 is 10 meters going east. Going east, is it positive or is it negative? Is it positive? So positive 10 plus 20 meters going west. Is it positive or is it negative? Negative. Negative 20 plus 10 meters going east. Is it positive or negative? Positive 10. And then when you enter this in your calculator, the total displacement will be equals to 0 meters. So you will have and may have situations where the distance is huge, 40 meters on this case, and displacement is 0 because you are starting and finishing at the same point. So if you are, let's say after school today, you are going to take a walk and saying you will go to a 7-Eleven or to a McDonald's or to a friend to work with him or her, and then you start from your home, go to your friend, after that you go for a walk, and then another trip, and then another trip. The distance that you are obtaining may be huge, maybe 3 kilometers, 4 kilometers, 5 kilometers. But at the end of the day, you will go to your home. That means that your displacement, since the starting point and the end point is at the same point, will be 0. Is it clear, guys? So now we have a second example, and we don't have a lot of examples to go on. So it's 4 examples, I think, in total. A man walks 35 meters east and then 185 meters west. So we are dealing here only in one direction. What is the distance and what is the displacement? So we'll start with the distance first. The total distance will be distance 1 plus distance 2. So in this case will be 35. Notice here I'm adding them without the sign. When you are dealing with scalar, you just add them without the sign that they are going to, in which direction they are going to. So you should have 220 meters. But when you are calculating the displacement, that will be d1 plus d2. Okay, those are vectors now. So going east is positive 35, yes, 35, plus going west is negative 185. So this will be in your calculator. Well, you will have something like negative 150 meters. You can leave it like this, or you can say 150 meters going west, because negative represent west. And now let's have an extension on this example. Even when it is, let's suppose that is, we have an example like this. I will extend this example, guys. So not dealing only with northeast, southwest in one direction, but dealing with different directions too. So let's have a 2 fraction 1 example. So let's suppose that we have this situation. We have, what did we say, 85, 35. 35 meters east, going east, and then 185 meters going north. The total displacement is this one here. So if we're finding the total distance, will be again 35 meters plus 185 meters equals to 220, I think we said, meters. But when we are finding the total distance, we will add the two vectors. And guess what? We know how to do this. We know how to do this. No, when you are, Brad, when you are saying that, when you are expressing the distance will be 220 meters. Not north, not east, not anything. But when you are writing the total displacement, then you will add them as you are adding two vectors using components. So this will be horizontal component, vertical component is the same what I was saying to you on the regards to that question. So this is D1 and this is D2, and we have the resultant that is D total. So the horizontal component will be positive 35, the vertical component will be 0, the horizontal is 0, this is positive 185, this will be positive 35 and positive 185. So the total distance in magnitude will be the square root of 35 squared plus 185 squared. Are you following, guys? Yes, yes, great. The total in magnitude will be in your calculator 35 squared plus 185 squared. The whole thing square root is 188.3, but it doesn't really matter. We can leave it. We will be safe. And then this as angle alpha will be inverse tangent of 185 over 35. So inverse tangent 185 over 35 will be 79.3, but it doesn't matter. So now the total displacement will be 188 meters at 79 degrees, and this will be north of east. Is it clear, guys? Let me know on the chat. This is another example. So a man walks 35 meters north and then south and then north and then finally south. What is the total distance and what is the total displacement? Please work on this and then I will get to you with the answers and probably with the solving, how to solve it. So a man is moving, walks 35 meters north and then goes south and then goes north and then finally south. So if we are drawing this, the situational diagram, you will see something that is going north and then south and then north again and then south. Now the vector that starts or at the starting point and at the end point will be the total displacement graphically. And this will be D1, D2, D3, and D4. So displacement for the first part of the motion, second part of the motion, and a third part of the motion. Good. The answers there are great. Good. Excellent. So now the total distance will be adding them without sign, considering the sign. and 785. So the total distance will be, what is it? 1324 meters. Versus the total displacement will be adding vectors plus d4. And now since those are in the same, or in collinear, in the same line, will be d1 going north will be positive 35. D2 going south will be negative 129. D3 going north will be positive 375. And D4 finally going south will be negative 785. Giving us a displacement total, if you use the calculator, will be negative 504 meters, or you can say 504 meters going south. Your answers were right. So you had them on the chart and they were right. The work that you need to do to support this is this one here. And this is the last example of the lesson today. So a man walks 75 meters west and then 192 meters east. And it is the time that is traveling is 90 seconds. What is the average speed? As we said, the average speed is total distance over total time. Okay, so now let's figure out what is the total distance. We know what is the total time is 90 seconds, not 90 seconds. Let's figure out what is the total time, distance. So as we said, distance is just adding them all together, 75 meters plus 192 meters, and this will be 267. Do you have this, guys? Yes or no? So now the average speed will be 267 meters over 90 seconds, which is 2.97 meters per second. Is that right? You can go 3.0, it's fine as well. Okay, so as you see here, there is no need for directions or anything like that. And now, what is the total displacement? So we have two motions here, D1 plus D2. And then going west will be a negative, so negative 75, plus going east will be positive. And then we will have 117 meters going east. Okay, if we add here, what is the average velocity? So velocity will be total displacement over total time. Okay, velocity and speed are corresponding of each other. So if we are saying velocity, then we are dealing with a vector, which means that we will take the displacement into the consideration. So this will be 117 meters going east over 90 seconds. And time is not vector quantity. And when you divide the two together, you will have 1.3 meters per second going east. So speed for the same motion is 2.93. You can say 3.0 to consider the sigdigs. 2.97 meters per second, while the velocity is 1.3 meters per second going east. So you define it, what it is, what is the direction that is going. And as you see here, even though that we are talking about the same motion, the speed and the velocity are two different numbers. So there is no surprises here. Okay, questions? So now you can work on those 5 practice questions. So the first one is telling you that indicate the positive and negative direction. So if you see something east, south, up, west, down, right, left, north, what does that mean? You know now that east means positive, south means negative, up means positive, west means negative, down is negative, right is positive, left is negative, north is positive. And then based on this, you will determine the distance and displacement for all those motions that you have here. And then you will see what is the average speed or the average velocity. So this is kind of emphasizing what we did in today's lesson. The answers for the questions are on the brackets, so you can take a look at them and then compare your work with the answer that you have here. And this concludes today's lesson.